Welcome to Math Rescue. This is the continuation of a two-part series on angles and arcs in trigonometry. If you missed part 1, you can click in the annotation on the screen to be directed there now. I highly suggest you watch that video first. In this part, we are going to cover angles measured in radians and the arc length formula. The first thing to deal with is the question I am most frequently asked: what is a radian? A radian is the measure of an angle formed when an arc of length r is subtended on a circle of radius r. That is to say, when the radius and arc length of a circle are equal, the angle produced is 1 radian. There are pi radians in a half circle and 2 pi radians in a full circle. Therefore, we have a conversion factor between radians and degrees because we know that there are 360 degrees in a full circle and 180 degrees in a half circle. To convert from degrees to radians, multiply by pi radians divided by 180 degrees. To convert from radians to degrees, multiply by 180 degrees divided by pi radians. Converting between radians and degrees is not difficult if you remember the conversion factors I just gave you. Let's convert 75 degrees into radians. Simply multiply by the correct conversion factor, which is given in green. The old degree units cancel, and then simply reduce the fraction as much as possible. When working with radians, the pi number is usually left in place. That is, you don't want to use the approximation of 3.14 instead of the symbol for pi, because your answer will always be an estimate. Leaving pi in the answer gives an exact number. Also, you want to use fractions instead of decimals for this same reason. You can write pi in the numerator or beside the fraction. Either way is correct. I prefer to write it in the numerator. Now convert 3 pi over 4 radians to degrees. Multiply by the correct conversion factor boxed in green. The old units should cancel, and here the pi cancels as well. Then multiply 3 by 180 and then divide by 4 and you get 135 degrees. You can also use your calculator to convert between degrees and radians. I cover that in more detail in the blog post, but here are a short set of instructions for you now. First, make sure your calculator is in the mode corresponding to the unit you are converting to by checking the mode menu. Change this setting if it is in the wrong mode. Input the angle you wish to convert, followed by its unit. The unit symbols can be found in the angle menu. The first option is for the degree symbol and the third option is for radians. Press enter and the calculator will make the conversion for you. I hope you can see now that using your calculator is not faster for converting between angles because you have to change the mode frequently. Also, the calculator will not show you radian measures in terms of pi. It will give you a decimal approximation. If you are using a calculator to check your own conversions, simply convert your answer to a decimal and see if it is the same. Otherwise, you can divide by pi and then convert the remaining decimal to a fraction to obtain a non-approximated measure. Now let's talk about arc length. The arc length formula is on the screen now, where s is the arc length, r is the radius of the circle, and theta is the angle measure in radians. This is important. When using the arc length formula, the angle measure must be in radians, not in degrees or in any other measure. If you're given the angle in any measure except radians, you have to convert it before using the formula. If you are given any two of the 3 variables, you can solve for the final variable. So if you're given s and r, you can find theta. If you're given s and theta, you can find r. And if you're given r and theta, you can find s. Here's an example. An arc of length 3 centimeters subtends a circle of radius 2 centimeters. What is the angle formed? First, I like to make note of what I already know. I know that s is 3 centimeters, r is 2 centimeters. I don't know the angle. So, using the arc length formula s equals r theta, I rearrange the equation to get theta by itself, and I get theta equals s divided by r. So now I input those variables, 3 centimeters divided by 2 centimeters, and I end up with 3 over 2 radians. Note that if the arc length and the radius were given in different units, say centimeters and meters, I would need to convert one of those so that they're both in the same unit. Otherwise, the equation does not work. Here's another problem. An arc is subtended on a circle of radius 3 inches and an angle of 56 degrees is produced. Find the length of the arc. Again, I like to make note of what I already know. I know that r equals 3 inches, theta equals 56 degrees. But wait, you can only use the arc length formula if the angle is given in radians. So we must convert 56 degrees into radians before we use the formula. I get that theta equals 14 pi over 45 radians. Now I can use the formula, and I don't have to rearrange it because I'm solving for arc length. S equals 3 inches times 14 pi over 45 radians, and I get 14 pi over 15 inches. And in this case, I want to approximate that value in a decimal form, and I get 2.93 inches. Most application problems dealing with arc length involve a pulley system. Let's talk about those types of problems now. Here are 5 steps to solving an arc length application problem. First, draw a picture to illustrate the problem. Second, label all important parts of your illustration. Use subscripts to distinguish between different parts of one item versus another. 3. Set up equations for the variables you've labeled. 4. Make a connection between equations if you have more than one. And 5. Solve for the unknown variable first before plugging in numbers to the other variables to avoid computation errors. Then plug in known values and find a final answer. Let's look at an example pulley problem. A pulley with a radius of 10 inches uses a belt to drive a pulley with a radius of 6 inches. Find the angle through which the smaller pulley turns as the 10-inch pulley makes one revolution. State your answer in radians and also in degrees. It may help you to underline all relevant information in the problem. Next, draw a picture that illustrates the problem if one is not given for you. I've designated the larger pulley as pulley 1, so its components use a subscript of 1, while the smaller pulley components have a subscript of 2. Next, I've listed all known variables. Notice that if an angle is given in revolutions, you can easily convert that into radians because there are 2 pi radians in one revolution. Step 3 is to write equations for the variables. Here I'm using the arc length formulas for each pulley individually. Step 4 is to make a connection between these equations. When 2 pulleys are connected by a belt, they undergo the same arc length but different angles. This is the connecting factor, and this is where students get lost on these problems. So I've set S1 equal to S2. Now you can plug in their corresponding equations and solve for the unknown variable, which in this case is theta 2. Once you've solved for theta 2, now you can input the values that you know and find a number. And I come up with theta 2 equals 10 pi over 3 radians. The problem wants you to give the answer in degrees as well as in radians. So now you need to convert theta 2 into degrees, and I get 600 degrees. And that's the end of the segment on angles and arcs. I hope this video has helped you, and if it has, click like below or subscribe. A link to the blog post that corresponds to this video will be provided in the description box below. Thank you.